So, hi guys, my name is Igor, and I'm a software developer working at United Cloud, and it's my colleague.
Hi everybody, my name is Miloš, and I work at United Cloud. I started out as an iOS developer, and later on I switched to Android, so I get a chance to see both sides of the mobile ecosystem. Lately, I'm working more with cross-platform development, mainly with Kotlin Multiplatform. And today, my colleague Igor and I will guide you through our journey with Kotlin Multiplatform, how we create the shared library for one of our key projects, Player, and how we later extended it with add insertion.
Okay, so for those of you who don't know us, at United Cloud, we provide technology for our clients to deliver video to the end user. And one of the major components of that technology stack is our Player. And so I'm going to take you back around 4 years ago, or 4 or 5 years ago. And talk to you about the state of our code base at that time. So we had we support all of the major platforms for delivering video, so Android Mobile, Android TV, Smart TV, iOS, and web. And so for one reason or another, all of those development teams implemented their own implementation of our Player. So for each platform, there was duplicated code. So what happens is that playing video is not only like you get a URL and play it. There's also a lot of stuff that happens behind the scene. So for us, main are URL formation, error handling, disaster recovery, analytics, and stuff like that. And so each of those implementations had their own code for it. Also, the client applications also had to communicate with a lot of different services. So, for example, we can see here that we have a streaming service which provides the video, but we also have a licensing service that handles DRM. We have the metadata that handles all of the stuff that needs to happen to form a URL and stuff like that. And so it kind of got complex pretty quickly. Also, not only the code, our development flow was suffering. So for every new feature that we had, it would usually start on the server, and then each of the client teams would implement their separate implementations. So we had basically 4 times development effort and 4 times QA cycles for a feature to be complete. And because each team had their own development cycle, they were not in sync. Sometimes one client would start a little later, and so we would not have a feature ready until all of the clients are complete. So we noticed an issue there. I will just like to point out, if you can see on this slide, there's an Android TV application, Smart TV application, actually shared a common code base. And what they did have is they abstracted some of the Player functionality through a common API, and then they had all of those side logic required to play the video in a single code base. But the issue was that was done in JavaScript for legacy reasons, and we did not want that for all of our applications. And around that time, Kotlin Multiplatform was starting to emerge as a possible solution. So I believe it was pre-alpha at that time. And so we took a gamble, right? We wanted to try and implement what Android TV and Smart TV application had, but for all of our platforms. And so a colleague of ours, he's in the audience right now, he took it upon himself to create a proof of concept, and that went successful. And so 3.5 years ago, we had our first commit. Yay. What happened 3.5 years later, now we have a single code base for our Player. So all of that logic that was on the slide before, like URL formation and stream recovery and disaster recovery and analytics and stuff like that, now have a common business logic. So, and we have a small wrappers for each of the platform for the actual producing of the video, so like video reproduction. So for example, for iOS, that would be Foundation AV Player. For Android, it would be Exo Player and stuff like that. And then what we do is we build and distribute that library hosted on our servers, and all of the clients can use that. And basically now they have rid themselves of the complexities. So now what it looks like, every application basically don't even know that there's a streaming service or disaster recovery or licensing service and stuff like that. Let's take it with a bit of grain of salt. They still have to know about it, but they now basically just collect metadata and they pass it on to the player, and now the player handles the video reproduction. Also, our flow has changed a little bit. So now, because we have this single code base for the player, we can now start developing together with the server, and we got rid of all of that duplication of the logic that we had. And so now, when a feature is complete, now all that's left for the clients is to integrate with our library. So the team that developed this is small. It's 2 developers and 2 QAs. And now the benefits that we have is that we have one shared code base, so it's easier for people to get into the code. We have a unified test suite across Android, iOS, web, and smart TV, because now the player is responsible for the quality of our product. And so what are the payoffs that we got? So we have consistency. Before, there were multiple implementations. And as you all know, there is a specification, but sometimes you as a developer have to decide how to handle some things, and those things can be different on different platforms. So now we have unified behavior on all platforms. We have a faster feature delivery, because if the feature is mostly common code, we write it once, so it's faster. And now we have also an unexpected benefit. It's focus. Client teams are now liberated from having to possess the video streaming knowledge. So video streaming knowledge is quite specific, and it can be complex and large. And so the client teams now, they don't have to know about it. They just use the player, and they can focus on improving their applications in different ways. And with that, after we finish player, I'm going to hand over to my colleague.
Thank you, Igor. So after we achieved the feature parity with our player library, a new feature arrived in our roadmap, and it was add insertion using VMAP, VEST, and tracking. So at first, we thought about adding this logic directly into our existing player library, but after some discussion, we realized that the player purpose should remain focused purely on content playback. So basically, players should know how and when to play an ad, but things like communication with ad inventory service or ad URL creation shouldn't be part of it. So we decided to create another KMP library for this feature. And this is how our architecture looks now. So basically, client sends an ad URL request to the ad library with the proper metadata acquired from the service. And then ad library sends that request to the ad inventory service. And after the response is returned to the ad library, it do the processing and sends back that response as a plain string to the clients. Then the client sends that URL to the player, who knows, as I already told, how to play the ad and when to play it. We support pre-roll, mid-roll, and post-roll. Also, I would like to mention, if you look at the right side of this diagram, you can see that all of our clients are still communicating with metadata service. So we have plans in the future to add another library there who will communicate with the metadata service, and all of the clients will use it. So the add library was developed by my colleague, who has previous experience with web and Android development, and me, and we managed to finish it in just a few weeks. This fast development cycle came from the fact that we reused the existing setup we did with player library. Things like Gradle configuration, CI/CD pipelines, and general project structure. And also this was a proof that Kotlin Multiplatform created a real scalable development model for us. Okay, so now, besides the fact that we took the setup from the player library, we also tried to pinpoint the main errors and mistakes we did the first time. So the main problem was how we started. At first, we implemented all of the features just on one platform. And of course, we chose the easiest one. It was Android. And our plan was to later reuse that implementation for the other platforms. But when we tried to ship that library for the web and iOS, things started to break. We have run into several compatibility issues that forced us to change our public API. Luckily, we were not in the production yet, but this was still a valuable lesson. So our advice to you is to implement at least a few main features early in the process, so you can validate that your architecture and your shared API design will hold up. So on the website, the biggest issue came from the fact that suspend functions are not exportable to JavaScript cleanly. So in order to see them from the JS side, you need to wrap them with promises. Later, we automated this process by using the KSP plugin, and developers don't need to do that manually anymore. Also, I would like to mention that we created this plugin for the player library, and later we reused it for the add library, and we'll reuse it also for our future libraries. Also, on the JS side, not all Kotlin types can be exported to JS side. On the iOS side, the biggest issue came from the fact that interoperability happens through Objective-C. We fixed most of the problems by using Ski Gradle plugin developed by TouchLab. So, as you saw, the interoperability can cause a lot of friction in the process, but by using the right tool and with a bit of creativity, you can achieve interoperability across all targets.
Okay. And so I'm just going to try and close this up by saying what we learned. So we learned that clear module boundaries are critical. So if you want to extract a piece of your business logic out into a multi-platform library, it needs to be like a clean design. Otherwise, it will not work. One advice that I would like to repeat is that you should implement every feature for every platform, or at least provide an API and then stubs, and then see if it will compile, it will work, so you don't have the problems that we had. The initial setup can be quite intensive, so the build scripts, the distribution of the libraries and stuff, it can take a lot of time to set up correctly, but once you do, you can reuse that for every next library that you have. So as you saw, we already have one ready plugin, and we also are starting to work on another one for another project in a KMP, so every time it should be smoother and smoother. Also, that was from the technical side, but it also improved our development cycle. So we moved our video logic closer to something that we call now video delivery core, that it's the server and the player library together. So it's one product. They can now involve it in sync because we're basically doing the same thing. And also one major thing is that client teams no longer have to worry about video delivery, right? And so I would like to say that it took us around a year and a half to reach feature parity. And that's because we not only had to build a library, we had to build also the demo applications to test out those libraries. So that kind of prolonged our development cycle. But once we reached feature parity with our current players, in just a year and a half, we added a lot more features to our product. So basically, audio track selection, subtitles, ads, offline playback, and more. And I would like to say that for example, if you remember that slide about development cycles for our subtitles, when the server and the player library finished the feature, all the clients had to do was bump up the player version, and they automatically got the default subtitles displayed. They didn't need to implement anything, basically. So after all that, it was a lot of trouble, but once we set everything up, we noticed a much faster delivery rate. So in conclusion, so for us, it was worth it. So thank you. Are there... if you have any questions, right? No?
I'm coming here to ask you if you have any questions. Do you? No? Ah, yes.
Yes.
Wait. Wait for the microphone.
Yeah, thank you. What about the performance?
So basically what Kotlin does is it compiles to the actual native, like for example for the iOS, it compiles to the native its native binary. It does have included the Kotlin standard library basically for that, but it's not a huge overhead for us. We didn't notice anything particularly troubling for it.
Okay, thank you.
Yes.
Hold on, pass the mic. There's someone else. I think maybe now's the time to say that Igor was really nervous. I think he did a good job. Don't you think so?
Yeah, he did. Well done, great talk. And I have a question, why Kotlin? I mean, was that the right tool for the job, or you were experienced with that and had...
No, none of us had the experience with Kotlin Multiplatform. We did have Kotlin experience before, so that was the logical choice. The other options, like we wanted to cover all of our platforms, but we wanted native code, so anything JavaScript was not in store for us. We had experience, we were not satisfied with that. So we tried native solutions. We could have done something differently, but Kotlin Multiplatform enabled us to go like full, from the UI to the business logic and everything.
And what other options you had in mind before actually deciding to use Kotlin for that?
If you don't want to use Kotlin, you can abstract away the UI stuff and do the business logic in basically any other language that has FFI that you can hook up into. So, for example, you can do Rust and then link it for every platform because it compiles to WASM and stuff like that. But Kotlin was our choice because of the UI. Yeah.
Thanks.
Oh, and also because all of us had Kotlin experience, so it was a logical choice.
Any more questions?
If you're too shy, we will be probably at the booth. You can find us. We can talk for hours about this topic. So,
see, that's what I was going to say. You two are dressed like developers. It's really hard to find you in a crowd, but now you have a booth, right?
Yeah.
Wait, which side is it on?
It's upstairs from this side.
Okay, so you know where to find them. Okay, good. So give it up one more time because I think you did a great job.